I'll just welcome you to the class. There it is. So we're talking about overloading and overriding. What does really means overriding and overloading? You've got a parent and a child. Yeah, a parent and a child. They'll go to our whiteboard here, and I've got a parent and I've got a child. Say, for instance, I've got a class. I've got a class. There's a class. Call it anything. Here it is, a class, and I'll call it X, the class. Then move this one. This doesn't look nice yet. Make it smaller. There it is. So I don't want to make a square. Make this one X. Yeah, class is called X, and I've got a class Y, and I've got a class Z. Yeah, as classes. And if I do this, here they are. Yeah. So you can do it either do it like that. It means X, Y, and Z are children of X. So when I get any one of these, I would say class. Right? I would say class. If you know, this is the way I can say it's public. Class, for instance, Y. Y, there it is. Let me just make sure it's a capital. Right? I can say Y. And then you can extend X, and it's a class. So you say that's Y is inherited from X. What do you really inherit? Inherit from X, inherit everything, right? If like inherit all the methods, all the attributes, but we're going to see there are some attributes explicitly you cannot inherit them. Yeah. The other thing is you don't inherit the constructors. Yeah, you don't. You inherit the methods, which says private and so on. But when it says protected, you say things are. We're going to see that in the future. So we don't. I don't want to touch on this as at the moment. Yeah. So what does it mean? That means Y and Z, they've got all the methods of X. Yeah, of the parent. That's what it is. Now, polymorphisms. What it says, which I explained that before. I can say simple. Here it is. I can say X, for a small y, equal a new Y. Absolutely nothing wrong with that, yeah? That means it means Y is of X type, yeah? But you cannot say, right? This one, you cannot say Y small x equal a new X, right? You cannot do that. Impossible to get the child to create the parent. Yeah, this is impossible. This is not allowed. Yeah, but this one is allowed. This is polymorphism. There are different types of polymorphisms. We're going to talk about implicit casting and explicit casting. Right now, let me show you on a class how we write the code for it in seconds. Yeah, that's the things I want to just touch on it today. There's a video on that as well. I'll upload that video how you do that, but I'm going to show you how we do it. Right, let me get out this way. Delete it. Yeah, and let's move to our job. See, and remember last time we talked about faculty, students X, person. Right, I can have a look. I can come in here and have a look at this one. And persons, if you notice here, persons, all we have you have the constructor and right, nothing else. I'm going to move this. Look at this one. Of course, I'm going to just take this away. Take this away for a second. Look what I'm going to do. I want to just put it here, then I'll move it afterwards. Look how you can do this. I can remove this one. Yeah, we can write this by hand, that's the best way you do it, so you can learn. Look what I'm going to do. In order to create this, right click here, and I'm going to say source. Give me constructor with the fields. What do you want? These three. So okay, done. Generate that for me. Can you see that? I generated. So I don't need D. I don't need this so far. Yeah, here it is. Now, of course, that's the one was here before, non-default. So I can move it here and I go to this side. Yeah, there it is. right? Now, if I create for all these are private string name, gender, contact number. I always go here, source, generate getters and setters, because you need set and gets for all the privates. Yeah, here it is. Yes, I want each one of them says set and get on it. Yeah, get and set. Right. Here it is. We do this by hand, but this can be done for you. Here it is. All the course been done. Is that all of everything has been done for us? Even if you want to create the two strings, it is source and it says give me two strings. Right? It can generate everything for you. Yeah, but you need to learn how you type that one and how you do it. Yeah, that's done. So I can go to faculty here. Faculty, of course. Faculty, all we have the same. You can do the same thing. For faculty, go faculty ID. It is. I can come here and I say, give me sets and gets. It is. Make sure it's outside the brackets. It is. Source. Set and get. Say there. Yes, I want faculty here. It's going to give me set and get. Because if you click on the arrow here, it says get and set faculty. There you go. Yeah, done. Same thing. You go to students X. Same things. Students X, I put students ID and I put GPA. Yeah, here it is. Same things. I go in here and source, sets and gets. And there you want them, both of them. Yeah. Yeah. Here it is. Yeah, done. However, just piece of advice. If you have this, I'm gonna add this and I'm gonna move it. If I have this one, private, static, here it is, int, opt equals 0, right? What do you say about that? Look at it, it's italic. Never, when it comes in here, the system allows you to do it, right? I come in here and I'm going to say source, get and set. I've done all of this for us. Look at the opt here, opt. Here it is, set and get. Never choose this one, yeah? Because this is a static. Static, it means belong to the class, not belong to the object. So all you need to do, read it only. So all you do, right? Click on, here it is. And what does it says here? You can maximize on this and you can see it. What does it say on it? It's a static. You can see static. Remember always static, never do set on it because it belongs to the class. Yeah, here it is. So never click on set. It allows you to do it, but don't do it because you're gonna make a mistake on it, right? Minimize this one. Here it is. Sorry about that. Try to minimize. Here it is. Only set. Here it is. Set. Get only, right? And generate. It's not generate only the get for it because belong to the class. This is just a piece. You don't do sets on it because always static is being generated every time you create object. If we allow it to overwrite it, it means you can play around with the object, right? Don't allow this one. Always just get on that one. So head, I'm not going to take it away. This is just piece of information in the future. Don't do that. Yeah, here it is. So we create all this. Can you start here? Now I come here. This is all be done. Can you see? When I come here and I come to my programs here, look at that. I can run it and I say, okay, run that for me. Yeah, here it is. The first one, I create person. Look at I create person here, which is I haven't done that last class. In person, if you go to person, yes, I'm creating an object of person. It goes to person and it comes in here. Here it is. Do you have any extents? No, there's no extents. So all it does says I'm inside the default constructor. Simple as that. That's what it is. Is that I'm inside default constructor. However, I'm just recapping our last class. Here, when I say person P2 equal new person, similarity, male, and that's the contact number. Yeah, look at that. But this is person. Can you see person? A person. It's still a person. So it goes here, and of course it says inside here, and that's what it is, right? See, inside. Because there's no extents on it, so it doesn't go anywhere, right? However, look at the third one, faculty F1 equal new faculty. So it's going to come here. Here it is. This is default constructor. There it is. It goes to where? To this one here. As soon as it comes here, it checks. Do I have any extents? Here it is. Extents. Yes, of course. So what does it do? Go to person, and you don't have anything here, right? So what does it go? This exactly same. If you put super like that, yeah. Is exactly the same. You put it or you don't put it. Default constructor, yeah? Here it is. You put it or you don't put it, it's exactly the same. So what does it do? Go to person here, and this the constructor, which is here. So it's going to come here. Is there any extended? No, there's none, right? So it's going to print it here. It's going to say inside person default constructor, and then it comes back to where? The faculty, because here, and then says inside faculty default constructor, and that's what you have here. Can you see this two here? Here's two, because I created. Here it is. This is statement here. This is statement. It'll give me the output. Yeah. Now I gave this print line here. That's up there. I guess student X. It's exactly the same thing. Go students X S, and it comes in here. Students X. Here it is, and it comes in here. This is student X. It says comes here. Do we have extents? Yes, you have extents. It gives you. It goes to the person. Person. I was going to say, of course, default one. I'm inside person default constructor, which is here, this one. It is this one here. And then it goes back to the students X and it says I'm inside default student default constructor, which is here. To prove that, remove the extents. Remove this extents here. If I remove this one, here it is like that, right? Of course, that's going to give me problems here, right? Causing problems here. I'm just doing it like that, yeah? Nothing, right? So I'll just come with this one. So look what's going to happen in here. What's going to say? It's going to go students X, S, new students X. It goes here, and it's going to come here, and then it's going to say, do you have extents? No. So it prints only this one, yeah? So this one will change only, print the last one, yeah? They run it and see what they're going to give us, yeah? Here it is. This is just recap of last class. Here it is. And you can see it. I'm inside students default constructor, because it goes there, students, there's no extents, so I print this statement. Here it is, yeah. However, if I add, here it is, extents, yeah, person, here it is, yeah, extends person. Of course, it's going to print the person, print this statement first, and then the second pair, this one, right? So run this program and see. That's going to give us two of them. Yeah, that's a recap on last class. Here it is. Yeah, can you see it? Yeah. Right. What I'm going to do, how would you add things? How do you change things and so on? How we print things and so on, yeah? Look at that. I've got faculty here, F1, there it is, a new faculty, right? Let me set the names and so on. Look at that. Why I said the child bring or inherit everything from the parent, yeah? And that's what the idea is all about. Is the thing is, if we go here and try to imagine here, imagine your code here. You've got the two classes, yeah? You've got, so that's it. I've got here, I have students, which we call students X, yeah? And I'm gonna have here, faculty, and then probably I've got staff, yeah, the staff, here it is, or worker, or right, here's worker, and I've got staff, probably staff, here it is. Try to think actually, what are the attributes of all of this? Can I need to move here a bit, students, across here, right? I'm going to come here, there it is, and this is students. Each one of them, each one, students, faculty, staff, worker, employee, anything, yeah? All of them, they share things like name. Everyone has got name. Age, gender, contact number, and so many things share. What you do, write the code in every class. You're going to say, I'm going to write all this, yeah? All you can do, take the common things between them, because staff has got staff ID, SID, for instance. Faculty has got FID. Students has got SID, it's got GPA, probably, it's got other things as well. But we're just try to make it simple. Each one has got name, age, gender, contact number, right? So what I do, I can do this, all of these. The common things, I take them, move them up. So I can create a class on the top here, and it is, right? And I move these ones inside here, right? I'd call it anything. If it's faculty, staff, and so on, I call it employer, yeah, or employee, right? So all of this because it's students, and I can add things to it as well. I can say they are all person. So choose a name for it. All the methods here, because they're private, you're going to make them private, and then it's got set and guess, all of these, because as soon as you put this here, for this one's here, there it is. Can I do it in one line? Of course you can, right? But this is just each one inherited from it. Yeah, you can put it different combinations on this one. So rather than doing this one, you can just one triangle and take branches of it. It's just exactly the same things. Yeah. So what happens now? Students, faculty, staff, they're going to inherit all the attributes, the name, the age, gender, contact number, plus all the methods in that class. Yeah, inherited by default. So I don't need to write. I don't need to write this set and guess. Get name, set names. Get age, set age. Get gender, set gender. Set contact number. Get contact. I can write it once. You see that's what's called reusability in object-oriented terms. Reusability means I write it once and I can use it so many times. So I can write these methods and the attributes in one class person, and I say all these actually inherited. So inherit what that terms here, this one, when I see the triangles here, that means I'm inheriting from it. All these attributes, I'm going to have them as well. Right. Let's see how I can see that, how I can prove that, how that works, right? Then I can move to override and overload, right? Right. Let's go across. I hope this is understandable at this one because we discussed this. Let's have a look at this one. So I've got, for instance, F1 faculty. Now, faculty, all we have here, if you notice, has got only faculty ID, but I says extend person. So that means from person, I'm going to get all of these: name, gender, contact number, plus all these methods. You want to see that? It's very simple. Here it is. You want to see? Just maximize a bit. Here it is. So I can come here, and I say F1 dot. Look at that. What I can get. Here it is. Get contact number. Get faculty ID. Is it? Get gender. Get name, and so on. If I want to do set, let's set. Look at the set. I've got, of course, I have only the faculty ID inside the class, which is says class faculty. But I inherited the contact number. I inherited the gender, the name, and even the two strings. Yeah, from the upper parents. Yeah, that's it. So I can say set. Look at that. I can say set name. That is name. I can do straight away. Set name, and I say that is. Well, here it is. Yeah, there it is. Right, there you go. All right, here it is. You want to set, that is F1, set, that is contact number, gender, that is a gender, male. Yeah. So straight away, everything's inside the parent is inherited for the child. A superclass and subclass. Yeah, that's what it is. Right now, F1 dot set contact number. Yeah, has contact. All of these are in persons, right? So I can say 9971 501234 11, something like that. So, yeah, here it is. You see that? That's been done. So as soon see that, so F1, it tells you actually. Look at that. F1. So I say set. Look at the set. Here I can go set contact number, which is part of the parent person. Look at that. Gender is part of person, the parent. Set name is part of the person as well. Set ID is inside faculty. Here it is. So I can use this one. Right? Here it is. Yeah, I can ID, and I'm going to say 1 or I don't know 17403. Yeah, it is something like that. Yeah, that's a number. Yeah, it's here it is. Sorry, here it is. Yeah, and sort it. There you go. Now, if I want to print, for instance, right? If I want to print, I can come in here and I can say system out. Print. Of course, to print, to get the data, is use get. Here it is. I'm going to say For instance, name. There it is. And I'm going to say plus, look, F1 dot get. Look at that. I can say get name. I can get the name. So I inherited that from the parents. So there's no point I need to write the code inside the child faculty. So when I get this one, that's going to give me the name of it, which is going to give me this name. Yeah, there it is. Well, if I run this program, yeah, and here it is. See that? Yeah. See that? It's changed. Yeah. And so the same things you can do with the students as well. The students here, for instance, say this. For students, I can say s dot set. Look at that. Set name here, name, and I can say, for instance, Muhammad. Yeah. Yeah, it is name. Yeah, and then all I can do is the same things. I can go and say system out print ln, and I'm going to say print ln, and I'm going to say name, same things. I'm going to say students name, it is as something like that, plus it is s get name, it is get name. Is that? It is get name. It is, yeah. So and all the methods are inherited by the child. So if I run this one again, and that's going to give me exactly the same thing. It's going to give me Muhammad Akram. That is, yeah, it is. You see, student's name is Muhammad Akram. Right. So that's explain this. Right. Do you have any questions on this before I move to the override and override and override? Right. Let's see. Probably I got a couple of questions here. I don't know. Can we have a longer chain? Of course you can. You can have as many as you want. Yes, of course. Yeah, yeah. Of course you can, Ghazi. It's not just limited to one. You can have parent, grandparent, grandparent, and so on. Yeah, of course you can have chain of these ones, but singular chain. Yeah. If you want different chains, you have to use something called interface. Yeah. Yeah, of course. It's not only one. Yeah, you can have faculty is a person is part of humanity, and so on. So you can have cups here. Make sense? That one? Yeah. Of course you do. Yeah. But what's employee and what's person? Right? Yeah. All right. You have to when analysis is very important. So what's the difference between an employee and a person? Both the same. Yeah. The only things the employee, if you use an employee, right, that students will be excluded. Yeah, I took students in, so there's no chance you can make that employee as the parent, because that means people working has got salaries and so on. But students, no, they just come to study. Yeah, so that's where you have a look at. Yeah, right. Do we have any more questions with this? First of all, before I move, let me explain a concept for you: overriding and overloading. What does it mean, overriding and overloading? Overriding, it means you have inside, if you look at your code, you've got a method is exactly the same name as in the parent and the child. Yeah, in the parent and the child, exactly the same method name. Yeah, otherwise it wouldn't be overloaded or overriding. What would I look at? Look at that. I will look at the output of it, the input of it. Yeah. What does mean the output? Is it the void? Is it the int? Is it things? What does it give me? And does it take any input? These are two things you need to have a look. Very important things. Yeah. Name wise, they have to be exactly the same name. Yeah. That's the third one. Here it is. Let me just take this one and explain this in details. Yeah. All right. Let me have a look at this one. Let's now have a look at this one. Let me just change the color on this one, right? And let's see first the rest of things here. Right. Look at this code here first. Right. Look what does it say. I've got A. This is very important. That's how we analyze this. You got a question on this usually. This is very important. So you know it's overriding or overloading. I've got A, and new A. So A is class, which is that is. So it's going to go. This class here. See that? There it is. Of course, a class does not have a constructor. It's got a default constructor. Yeah. So really in class A, it's got public A, right? Empty and goes super and empty. So it's create an object B because B is the parent and A is the child. So look because that's going to come here. It is. Now, what's actually called an AP? P is a method. P is a method because it's got a bracket in front. So let's have a look at P. Here's P. Do you have one in parent? Oops, yes, we have. It is. Yeah. So we have two names. Yeah, exactly. One in the parent and one in the child. Now I want to know is it overriding or overload? I want to see what the output is, right? The output is what comes after public. Here it is. They are public, both of them. That's fine. Void, void. So it's up to now, it's still exactly the same thing. Now look at the input inside the bracket. This one takes double I, and this one takes double. The input is double. They are identical, right? Identical. What does it mean identical? Everything exactly the same. So what does the system do in that case? It goes to the child. Be careful. It goes to the child first, right? If it doesn't exist in the child, it goes to the parent. Yeah. If it doesn't exist in the child, so this one would go to where? It goes. This one it exists. So and exclude that one. So that is going to give me. Here it is. Print I. So that is the output here. The output here is going to be 10. Yeah. And then look at the second one. A question you're going to say, well, 10 is an integer. Integer is part of double. Yeah. Here it is. Now send in A.P 10.0. Now it's got to go to the child. Does it exist? It goes in here. Yes, this is double. Has double inside. It's got a child. It does exist. Yeah. That's it. Oh, it's going to print this one. This is going to give me as well 10. Yeah. So what does it mean? This means both the parent and the child have exactly the same things. This is called overriding. Yeah, I'm overriding the child. The child, it means even though I inherited the method from the parent, I've got my own behavior, my own characteristics. That's what it is. That's what real life is. Yeah, it means I can do things the way I want it. I don't need to be identical to the parent. Yeah, this is called overriding. However, look at the second one. Next to it is exactly the same things. A, here it is. And I'm calling the method P again. But look at the P. Before you look at the numbers and you do the calculations, go to the methods and see how the methods works. Yeah, look at them. Are they identical? Both of them. Public void P, it is both of them public void P. Look at that. The child takes integer input, while the parent has got, it takes double. One takes child, one takes double, one takes it. They're different inputs takes, right? And this one is called overloading. Overloading, look at that. Overloading here. Yeah. So what's the system? How that's gonna work? Here it is. AP, this is going to behave differently. AP, here it is, AP 10. 10 is an integer in this case. It's going to insert here. It's going to go to the child. Here it is. This is going to go to the child here. I'm looking for integer. Oops, yes, I have integer, right? So it's going to go here and print it. So the output here is going to be 10. Yeah. Look at the second one. Second one, it says A.P 10.0. 10.0 is double. So this is going to go here. It is. Checks on the input. It says, oops, sorry, you take integers. I don't want that. Let me go and ask your parent if the parent has it. So what does it go? It goes the same methods here and says, oops, yes, it is double, right? And goes here. So what's the output? I times 2, and the output is going to be 20. Yeah. So this is what's overriding on the right-hand side, and this is the other side. This is overloading. Yeah, they have exactly the same but different inputs. Usually different inputs. Yeah, let's have a look at this and look how our classes and see if that's it works. Yeah, what I'm gonna do, I'm gonna just go to the class here. Here it is, and I'm gonna create a method inside person. Yeah, I'm going to say, for instance, I've got a method called, I'm going to call it public. void, very simple, print me. Yeah, doesn't take anything. Yeah, here it is. See that? Print me. Inside print me, I'm going to say system out print ln, and I'm going to say inside. I'm going to say inside print me person print me. Yeah, person print me method. Yeah, yes, method. That is, yeah. See that? There you go. Yeah, and I'm going to take the exact same things here, same method. I'm going to put it inside faculty. Here it is, faculty only. Here it is. Put it in here. Here it is. And I'm going to say print me, and I'm going to say I'm inside faculty. Here it is. You see? Print me method. Yeah, here it is. Inside, this is F, and this is person. Yeah, here it is. So what I'm going to do, I come in here, and I'm going to say, here it is. All I'm going to say, here's the faculty. Here it is. So I'm going to say here, and can come here after this be printed. Here it is. I'm going to say F1, print me. Here it is. Yeah, print me. Now, what's that going to happen? Look at that. Print me inside person. Here it is. Void, print me name. Doesn't take anything. Inside here is exactly the same thing. This is called overriding. Yeah, exactly the same. Everything exactly the same. So what's going to happen here in this case? Here it is. This one, after I print the names and so on, here it is. When it says print me, it's going to go to where? To the child. Here. Do I have the method? Here's the method. Of course, I'm going to print it, and that's it. Yeah. So I'm going to do this, run it, and see what they're going to give me. Should say I'm inside the print me of the faculty. That is, which is says here it is. I'm inside faculty print me method. Yeah. However, look if I do with students here on the students, and I'm going to say here it is S print me method. Yeah. Look at that. So what's going to happen is I print me. Now go to students. As students, go to here and says I'm searching for print me. Do I have the method to print me? No, it doesn't. So what does it see? This is inherited from person because I don't have it. It's inherited. It sees this one. Yeah, that is. And if you run it on the students, it says is a person print me statement, which is it is. Yeah, see that? Yeah. And actually, when you write it, you need to understand how this, because when you write it, you can see it. Here it is. By the S, and I say print me, it says, look at print me is in person. Yeah, this one. Here it is. While if I do this here, F1 dot print me inside faculty because I have it. Here it is. Yeah. Now, what I'm gonna do something else. Yeah. I'm going to print, or I'm going to get results and see. And I'm going to make it overriding rather than overloading. Yeah, I'm going to call it overloading rather than overriding. Sorry. So I'm going to go to print me on faculty. Look, I'm going to change it. I'm going to change this one faculty. When I say print me, here it is. I'm going to put after it. I'm going to say system. So I put here, I'm going to take an integer, for instance. Integer, I'm going to get double. Double, that is, or integer, and we make it integer. Int, right, x. Yeah, and I'm going to say, of course, you can, if it's void, it's going to be just inside. I can return it and I can print it. Yeah, I can say system out print ln, and I'm going to say value is it is. I'm going to just put something here. I'm going to say x. Yeah, value of x. That is. Yeah, just x. Now this one takes integer. Now I'm going to change this one person, and I'm going to make this one takes double. Yeah, so here it is double. X. There it is. And all I can do it is, for instance, I'm going to say system out print ln. And I'm going to say it is, I'm going to say value, exact same, value is and then I'm going to say plus math, probably power. Yeah, it is the value of x to the power of 2. Yeah, square. Yeah, so this is going to give me square. It is if I give it double, while the other one is going to give me. The only thing is I'm going to create a method as well. It is public. Yeah. Let me take it as it is here, and then I can change it. It is. Look at that. Yeah. Right. This is I'm doing overloading here because this one doesn't take anything to satisfy for the students. That is, yeah. And because students is causing it's print me. Come for print me with empty, right? Let me run this program. Look at that. Faculty print me, and I'm going to say I'm going to do two things. Yeah. I'm going to say one is going to say 3. Yeah. 3.0. Right. That is. And the other one is I'm going to say F1. Right. Print me. Here it is. Yeah. Print me. Look at that. Print me. And I want an integer. Here it is. Integer. Here it is. Integer. And I'm going to say 3. Look at this one. What's that output is going to give me? The first one, it says F1 print me. This one, print me. Maximize a bit for you. Here's a print me 3.0. So what's that going to go? It go, of course, go to the faculty, which is F1. F1 faculty is going to come here, and it says, remember the value inside is actually double. Yeah, it's going to come here to faculty here, and it says, all right, here's a print me. But it looks at that, says, oh, print me is actually it's integer, right? It says no. Actually, I'm looking for up. I have to go up to find the double one. You can put double here, one here if you want to override as well, right? Here it is. So I go to person and says, do you have actually one with double? And it comes here. Yes, I have double here. So what's the output is going to be? System.println. I am inside person print me method, and the value is to the power of 2. So it's going to give me 9. Yeah, I can make it to the power of 3 if it's the case. Yeah, make it power of 3. So it's going to give me 3 to the power of 3 is 27. Yeah. Now the second one, when it goes here, that is right. Input this one here. They will test it first. Right. Test this one here. Can you see that? Test it. That should give me 27 because the child takes the child, which is this is faculty here. It goes here and says, yeah, this takes integer. I'm sending. Actually, I'm sending here. If you look at this one, I'm sending a double. So because child doesn't have a double, it goes to the parents. Say, do you have actually do you have double? And it gets also a double. So it give me this output. I'm inside person print me method, and then says value is here it is 3 to the power of 3, which is 27. Yeah. So let us see moment of truth. Here it is. Run it, and here it is. Value is 27. Why? Because 3 is a double. You can see double, and double only inside the parent, not the child. Now look at this one. If I put a 3 on its own, there's a 3, right? Then put this one here. Here it is. So what's the output is going to be? Look this again. Here it is. Print me, and this is integer. In case, right? In case we don't have an integer, it takes it as a double. Yeah, 3. In that case, it'd be a double. Yeah, here it is. So it goes integer. It says, oh, I have integer. So it goes to faculty here. It says, oops, I need integer. It says, oops, it's fine. So it's going to say, I'm inside faculty print me method, and the output is going to value is the value itself. So it's going to be 3. Right? Run the program here, and look at this. Here it is. Value is a 3. The child, because child's text actually integer, right? However, probably somebody asks and says, well, if I don't have this, right? If I don't have this method here, what's going to happen? There it is. This method doesn't exist like that, so it's there, right? So what's really going to happen? You see that? What's really going to happen here? Here it is. This, remember, a 3 is part of a double. The integer is part of a double, yeah? But double is not part of integer. Yeah, remember always, integer is part of a double, but double is not part of an integer. Yeah, here it is. So this is an integer. It's going to come here, goes to faculty. Do you have it? It comes here. No, it doesn't exist. It's go to the parent. Here it is, the parent, and it says, oh, I've got one. I've got two. One, actually, this is overloading. I've got one, but it doesn't take anything. That's, I don't need that. But this one, it says, yeah, but this takes double. Well, I'll take it because integer is part of double. There's no alternative. What's going to give me now is exactly the same things. Yeah, run the program. Yeah, and see what they are. Yeah, it's 27. Can you see it? It's 27 because integer is part of a double. Yeah, I hope that's understandable. What I'm going to do, I'm going to put them together. There it is now. So what's the output here? And I'm going to come here. Of course, what's the output in this case? This is going to be 27, both of them. Yeah, both of them. Because I don't have anything in faculty, I don't have it. Yeah, here it is. You see, both of them, 27. Here, 27, 27. However, if I enable the one here, here it is. Here it is. What's going to happen? The first one is going to give me 27 because go to the double, while print me with a 3 is going to go and print me 3 only. Yeah, that is. So it'll be 27 and 3. That is. One is in the first one because a double, it gives me I'm inside person printing method, while the second one says I'm inside faculty printing method and give me 3. So 27 and 3. Here they are. 27. I'm inside person and print this one, while the second one give me here it is because one integer and one dot. And this is exactly what's overloading and overriding. Yeah, I hope that's explained everything. What I'm going to do, I'm going to just pause a minute, yeah, and see if we have any questions. Yeah, right. Let me just let me see the questions. Can you add more values in the child when you override? What does that mean? Is confused with that question? What does that mean? Yeah. Can you add more values in the child when you override? Of course you can. Yeah, of course. It's not always one input. The overloading is usually you have probably more than one input. So it will double and strings, and one of them have something. Overriding, typical overriding is two-string methods. Yeah, two-string methods is overriding method. Yeah, and to see that, right, I can go to the class here, and look what I'm going to do. I can come here, the class, packet for instance, here it is, and look what I'm going to do. It is. I'm going to say create. It's overriding, yeah? It's overriding the print statement. I'm going to go to resources. Sorry, no, this one. I don't want this one. I want this one. Resources. Here it is. And I say create two strings for me. Right, here it is. Yeah, two strings. What do you want? I want just faculty IDs. You want methods? Right? No, I want the other ones. You want inherited ones? Yeah, I want the name, gender, contact number. Right, that's it. Yeah, generate and generate that for me. Can you see it? Here it is. Generate all that for me. So as that's, can you see what does it say on it? It says override, because two strings it's override. Of course, when you do that, then you can change a few things, faculty ID and so on. Yeah, the name, get name, because inherited. The best thing is to use super, just in case, super dot. Yeah, dot. Get name and give you it's of the parent, so you know what that's it's coming from the parent. Yeah, move this one, and you can design that one as well. Right, let me just go through it here. It is, and see what that means. Here it is. It's called Inheritance and Polymorphism Simply Explained by myself. Right, here it is. This is something to talk about inheritance. When you click on this, that gives you a video. What's the inheritance and what you have some. What's these terminologies of inheritance? What's superclass, subclass? Why is reusability is all? What does it mean here? And then we talk about polymorphisms and where polymorphisms came, right? It means different ways we can look at different the object. So the word poly means many, and morphs, it means forms. So really, polymorphism means many forms of looking at the object. And thus, the example I'm going to talk about is today, this one. Shape, I've got a circle, and I've got a rectangle. Look at them, right? All of these. So this typical example, I'm going to have a look at this one, and this is the code for it. Here it is. Now, all of this inside has this. How can I copy up objects? Here, we've seen this before. Now, how can the copy objects? Look at this ones here. How can I do this one? There it is. These terms of polymorphisms. There it is. What happens really when you copy in objects as a video as well? Copying objects, videos. Yes. And then, which is important, dynamic arrays. Creating dynamic arrays can be done using array list. Yeah, array lists usually remove rigidness of creating an array with fixed numbers, which we've done in your first lab. Yeah, so all of these, each one of them is got linked to video, right? This part up to now, I wrote it up to now, so that would help you to have a look at. Is available. So have a look at this one and tell me if you need any help with that one. Yeah, so that's where it needs. Yeah. Now what we're gonna do here. I'm going to go back here, and I'm going to start talking about polymorphisms, right? So we're talking about overriding and loading and so on, yeah? And that's what extends and so on, yeah? So we're familiar with this one. Right. Look at this one. The two strings, we've done this already. So we know two strings as the printer string, just put it inside. It's overriding, and I've just explained this before. Polymorphisms. What does it mean, polymorphisms, right? Polymorphisms, I can use the parent, which I've just said before. I can use the parent to create the child, right? I have food, or I have persons here. In the class we've just done before, we can do this. Here it is here. Person, students, and so on. With this one, I can write, here it is, simple. I can come here. Share the screen, yeah, sorry about that. Here to go. Right. It is. Sharing the screen differently. So about that. There you go. Yeah, that is. So we have it here, and it is coming here. I've got this, for instance, and I can say person. Here it is. S equal new. So that's I can say new. Here it is. Students. Here it is. Yeah. What does that mean? I'm using the parent to create the child. Yeah. Here it is. Absolutely. It's not wrong with that. It means a student is a person. Yeah. The same things. I can say person F equal a new faculty. Yeah. So I can go to my class here. Here it is. Simple one. I got the class here. And look at that. I can go in here. This one. And I go, for instance, I've got sorry, let's go to the test. There's a test here. All of this. I can go here, for instance, I've got faculty here. Here's the faculty here. It's faculty. There it is. And I can say, rather than faculty, I'm going to say person. Yeah, person. Person. Right? Here it is. Yeah, and it works. It works. But look at that. It's causing problems here. Yeah, I can create person or faculty. Yeah, I'm gonna put the faculty here. It is. That is. It is. Yeah, faculty. This is faculty. Now, what I'm gonna do? I'm gonna create. I'm gonna just remove these ones, or can I? I can go to students actually, rather than students X. Yeah, here it is. Get name, and so that's been set here. Yeah, and I can come here. For instance, I can go on the faculty here. Faculty, or I can create students. I can go students, remove the students here. There it is. Here it is. So students X, I'm going to create one. And I'm going to say this is, name is Muhammad Akram. Here it is. Comma. See, first of all, before you send anything, check on the order of your, right? The one on students. String name, gender, contact number, student's ID, and GPA. Yeah, that's needed 5 of them. Yeah, so here it is. Remember, here it is. So I've got name, gender, contact number. Here it is. It is. Gender is M. Contact number, it is 971 50 123 9999. Something like that. So it is. And what does it need now? ID. It is. Say the ID is 20. It is. And of course, DGPA, and what it is 3.76. Yeah. Yeah. And that works. Yes, it works. Because I call here students X needs, here it is, name, gender, contact number, student's ID, and GPA. What do you do here in that case? You send, if you don't use this one, of course use default one. Otherwise, you're going to say, I'm going to go to the default non-default constructor, which it needs. Look at that non-default constructor. It needs name, gender, so string, char, gender, and contact number. Don't when you come here inside faculty or students, inside the students, never put this is string name and so on. Just the values. Name, which is this one, gender, this one, contact number. Don't use string and don't define this way. Define them inside the constructor itself. So I'm sending these data, and of course I'm checking just on the student's ID, which is here, and the GPA. Yeah, right. So we can create part of it. Yeah. So the thing is, I've created one here, objects here. See, that's as an object. Here it is. Yeah. I create an object, all of this here, and I'm going to create an object. It's called, here it is. I'm going to say person. Here it is. Person, and I'm going to say S2 equal a new, here it is, students X. Yeah. X. Yeah. Nothing wrong with that. It's fine, absolutely fine. I'm using the parent to create child. However, look what I'm going to do. I'm going to do this. Yeah. Rather than doing this, I'm going to say, of course, I've got this one here, and I'm going to say yes, S2 equal S. Right? S after nothing wrong with it. Can you see it? Nothing wrong. Accept it. Straight away, accept it. S2 equal S. Yeah, can you see that? S2 is equal S here. It's absolutely fine. Nothing wrong with it. Yeah, because this is called implicit casting. Implicit casting. Yeah, but I cannot do the other way around. I cannot do if this one, here it is. Even if I remove all this, right? I'm going to remove all this here. I'm going to remove everything, and I'm going to say just use the constructor. I'm going to go here. I'm going to say, look at that. If I say students X S equal new students. Yeah, here it is. Right? A new students X. I'm sorry. X. Yeah. Right. Nothing wrong with that. Look at that. What I'm going to do, I'm going to say person. Here it is. Person. Look at person here. Now I'm going to create S2 as of type. We know person is a students. Yeah. A students is of type person because S is a person, students. Look at that. If I do this and I say, that's going to give me an error. Students X. See that? It's giving me an error here. You see? Why? Because it says you cannot do that. What do? You have to say before what we've done. When I say person and the students, when I say this, that was students, this students, that's it, right? Person, students X, sorry, that is right. Students, and this is person. Remember, person is the parent of students X. So absolutely, there's nothing wrong with that. It's called, this one is called implicit. Really, this one's called implicit casting. Yeah, it means really, even if you do this, you say person, yeah, like that. Yeah, that's what it is. It should work like that, but it works without it. Yeah, because it's a parent. I'm going to just explain it in primitive data, integers and doubles and so on. Now look at this. What do? Here it is. This is a person. Look. Always remember the object is students because look at the right hand side. Don't look at this one. Look at the right hand side. Students X, yeah, because that's students X here. Now look at this. I'm going to call this one. I'm going to do look at that. X something is called explicit. Explicit casting, yeah. What does that make explicit casting? Let me take this away, yeah, like that, and I'm going to do this. Here it is. Remember, this students X is a type of object of the parent person. Look at that. I'm going to say students X equal, right? Students X S3 equal S. Hates it, doesn't like it, because says, excuse me, this is of type students X, but this one, even though they're the same object, looking at it yourself, as a human, look at that, we know exactly they're both exactly the same things, yeah, the same objects, but the computer says, no, this is of this type, person, and this is of type X. So what do you need to do to make it work? You have to explicitly cast it like that. Here it is. It says, I know it's S actually is a students, but cast it to me to students X. Do that, and I'll resolve it for you. Can you see that? Resolve it. This is called explicit. It means you have to write actually the casting. While this one, you don't need to write it. Write it or you don't write it, it's absolutely the same, right? Which is called implicit. This one, implicit casting. If you use the parent to cast, it's fine. But if you use the child to cast the parent, no, it's not possible. So you have to explicitly cast that one. Yeah. Let me explain this one in a bit of details for you how that really works in simple terms. Yeah. Let me go on here. I'm going to create a class. Here it is. I'm going to create a class, simple class, and I'm going to just show you where you use it. Use it all the time without noticing this. Here it is, a class, and I'm going to say, I'm going to call it test polymorphisms. Yeah, polymorphisms. There it is. It's got main. There it is. Yeah, I just want to see it. There it is. Look at that. I've got a class. It's a class. Just want to test it. There it is. Right. I'm sorry. It's not here. That's good. Yeah. Yeah. Assume I've got int x all 5, and I'm going to say double v equal math to the power of, look at that, x, which is 5 integer, yeah, and to 3, so, right, to 3. So that's going to give me 5 times 5 times 5, 625, yeah. So you see, there's no error. System out print ln, and I'm going to say print v. So v should be 625. 25 times 25, yes, 625. Here it is. Yeah, run this one, and here, sorry, 125. Yeah, times 5. Yeah, it's 125. Sorry about that. Yeah, right. Now, where would I see that implicit? Right, this is implicit. Can you see that? Now, let's have a look at this. Now, if I say, I'm going to print this statement here. Yeah, and I'm going to say here. If I put this here, and I'm going to say a print. For me, I'm going to say value is, I'm going to put a space here, and I'm going to say it is print 5/2. Yeah, what's that going to give me? Look at that. The value integer is 5. Divide by 2, right? It doesn't give you any double. It gives you 2. I'm going to change it to next one, actually 15. So that's going to give me 7. If I run this program now, that should give me 7. Yeah. Can you see it? 7, that's 2, not 5/2, I'm sure. As x over here. Yes, sorry. It is x, so that rather than f. So x, which is 15/2, is going to give me 7. Right, here it is. And that's going to give me 7. You see it? Now, this is, right, in order to make it double, it says explicit. Not really. Look at that. I can do it implicit. I do. Here it is. Yeah. If I put 2.0, implicitly, x it becomes double. See that? Here it is. So when I come in here and run it, it's going to 7.5. Here it is, 7.5. Implicitly, x changed to be double. Right? Why? Because integer is type of double. It's part of the double. Yeah. So when I say over 2.0, that's what's going to happen. Yeah. So that's really what's going to happen. It's converted implicitly, right? However, look at that. If I want to convert double to integer, I have to say explicitly, I want that to be integer. How do I do it? Here it is. Look at these numbers here. For instance, I'm going to say double number equal, I'm going to create random number. Math dot random, that is, times 50. It's going to create random numbers for me between 0 and 50. Now, there it is, right? If I want to explicitly, if I want to say int value, there it is, because if I print this one, I can say system out print ln, and I'm going to say give me what the number is, number. Yeah, that is sorry. Yeah, it's number. That's going to give me every time I run it, it's going to give me a different number. Yeah, every time. That is because it's random number. Run it, and here you go. Can you see it? It's a big number here. Here it is, big numbers here. Run it again, and voila, there it is. Run it again. It's going to give a different number. Here it is, 4.69. Here it's 26.79, and so on. You see that? Here it is. Yeah. So let me just get this out of the way. Here it is. This one is implicit. Probably we'll learn this one implicit. While this one, no. If you want to do it, it has to be explicit. If I wanted only, here it is. So if I run this program here, it is. Yeah, run it again. Here it is. Give me every time I run it, it gives me different values. Now, really, what would I do in that case? If I want only this part, the 27 or whatever it comes in here. So here's a math, right? And I want to create, for instance, an integer. I want integer. I can say int value, for instance, value, and I'm going to print value. I'm going to print number and value. That is, I'm going to say plus, give me space t, and then give me space value. Yeah, that's it. So I'm going to print the number being created and the value. Here, I cannot say equal number. I can't. Yeah. Why? Because double number is double, while int value is integer. You cannot, right? You can do number equal int. Fine, you've done that before, right? What you do, you have to say explicitly. You have to say int. I want the integer part, right? It works. Yeah. Explicit. This is called explicit, right? Casting. I'm casting number because double. I'm casting. Give me only the integer part of it. That's what it is. Yeah. So when I run this program now, it's going to give me right one with the only integer part, and the other part is here it is. So I run it. Yeah. You see that one? 47.58. It says actually 47. Here it is. Run it again. Yeah. And here it is 40. Do while on it, while statements, and so on. You can do the while statements. And now, usually, we don't do it like that, right? We don't do its values like that. What do? Here it is. You cast it straight away. So I can say int, because math.random, what does it give me? It gives you double, yeah? The output, because it says the output is double. Like you see, you cannot mismatch double to integer. So what do? In that case, here it is. I'm going to say int, right? And I'm not going to print value. I'm going to print only number. Here it is. It is. So I don't need value, just the number. Now, this is going to cause problems here. Look at this one. All the values here, be careful. All the values here is going to give me 0 here. Now, the question is why? It is. So whenever I run it, give me 0. Yeah. Here's a 0. Run it again. 0. Run it again. 0. Reason for that, because the casting, it takes only the first part. Can you see it? It casts really, because I did put in the bracket, it casts only this. And this always between 0 and 0.999. So always take the integer, which is 0. And that's why, what do you do? If you want 50 is part of it, between 0 and 50, with the bracket around them both. Yeah, that is. It says cast this to me, for me. Here it is. Right. When I run this one, now it works perfectly. Here it is. Run it, and see that one? It's going to give me numbers now. Here it is numbers. Yeah, run it every time. Numbers. And of course, sometimes give you 0. So if I want to see how many times actually to run give me 0, of course, all I'm going to do, it is, I'm going to say int number. I can just this text of trace equal, for instance, give the number 100, any number, yeah. Not touching this one, and I'm gonna remove this one. You cannot define one twice, yeah, to integer because it says integer. Here, I'm gonna come here and I'm gonna say while, there it is, while, there it is, number not equal 0, yeah, there it is. I'll put the brackets here. Remove all these lines. There it is. There it is. And of course, close the brackets here. But what we need to do, how many times? How many times I'm creating a counter and count, for instance, equal 0. There it is. And then what I do here, every time, look at that. How many times? So I'm going to say print count for me, plus, give me a tab, plus, right, number, right? And then what I'm going to say, I'm going to increase the count by 1. Here it is. So I can say count, here it is, here, plus, because you don't want to start with 0, start with 1. Here it is. You put it here, and let's go. So if I run the program now, look at that. Every time I run it, it gives me different values. Here it is. Run it here. Look at the values it's going to create. Here it is. Create all these. 22 times, look at that. And look at the values between 0 and 50 or 49. So it is at 22. We'll run it again, be different. Here it is 35. Yeah. Next time, here it is. It's 20. And so on. Yeah. Look at that. 50 times. 50. And then you go again only 4 times. See that? And of course, so it's because it's random. Look at that. 290 times in order to get 0. You go all these values, right? Random numbers, you can generate random numbers, frequencies, and so on. You can do lots of this. But the idea is very important. Here, this is a double. This one give you a double, right? And of course, number is integer here. So in order to use it, you have to make sure explicitly cast it to an integer. Yeah. However, integer to double, you don't need to, because you can say divide by and put 0.0, right? This one is called implicit casting, right? It's exactly the same concept. So look at the integers doubles is exactly like person and students, right? The same things, because person hold, right? The students as part of the persons. Yeah, that's the philosophy, the concept of it. Yeah. I hope this is understandable. Do you have any questions on this before I move forward with this? Yeah. Right. Ghazi asked questions regarding this. It's of course uploaded. Yeah, it is uploaded. Yeah. Says any question of the class? No questions. Have you uploaded this or not? Right. Upload. You can check on Blackboard. It's uploaded there. Right. Right. What time is it now? 4:30. I think we finish here, so I can start. I start polymorphisms in details next class. Right. Well, thank you very much. If you have any questions, please let me know. Right. Any questions at all? Right. Meantime, I wish you best of luck. Right, and the exam is going to be next week. I'm going to send a few things. Assignment is coming your way as well, inshallah. Right, and regarding the exams, I think it's next week. So I'm going to announce that one. We're going to do activities next class as well. I want you to be prepared of it, like 2 marks, 3 marks, and so on. So we accumulate on these ones, right? Should you have any questions, please don't hesitate to contact me at any time. And please stay safe, right? Thank you very much. Wish you best of luck. You take care.